Hello everyone. So today we're going to explain what is measurement system analysis, MSA. MSA is one of the most critical core quality code tools. Okay, there are six quality code tools are there: APQP, control plan, PPAP, MSA, SPC, and FMEA. So MSA it is one of the most critical and important quality code tools. MSA it is currently running fourth edition. The manual of the MSA was developed by AIAG, Automotive Industry Action Group, North America. Okay, now we need to understand that what is the definition of MSA? What is MSA? So measurement system analysis, MSA scrutinizes every components of the measurement system and it tells from where the variation is coming. Whether the variation is coming from the instruments or it is from the operators or it is because of some established procedures or it is because of some environmental factors. So measurement system analysis it is a structured method to evaluate the accuracy and the reliability of the measurement system. It helps you to understand whether the measurement system is reliable or not. MSA is basically done before SPC. Why? Because until unless your measurement system is reliable, how can you control the process? That's why MSA is so important and is done before SPC. Hello, this is Surajit Banerjee, a Lean Six Sigma Master Black Belt. I welcome you all to our channel, the Lean Six Sigma World, your go-to place for mastering the concept of Lean Six Sigma in all aspects. Now, we need to understand that what are the different components of measurement system analysis. The key components of measurement system analysis are basically accuracy, precision, bias, linearity, stability, and Gage R&R. Accuracy means what? How close is your observed value to your target value? That is your accuracy. Precision means what? It is the consistency among repeated measurements. That is basically your precision. Bias means what? It is basically systematic error. Suppose you have vernier caliber. It is from 0 to 150. So 0, 10, 20, 50, 100, 150, all this. So at any particular point, if you check the measurement, so what is the difference between the actual value and the observed value? That is basically your bias. Now, if you take the bias at each and every point throughout the measurement range, you will get linearity. Now, stability, it is the ability of the measurement system to give the consistent results over an extended period of time. Whether you are taking the measurement today or after 1 month, after 3 months, after 6 months, it should give the consistent result. Whether you are taking the measurement in summer season or in winter season or in rainy season, it should give the consistent result. That is basically your stability. And Gage R&R is nothing but gauge repeatability and gauge reproducibility. Repeatability comes because of the errors from the instruments. Reproducibility comes because of some errors of the operators due to some skill deficiency in the skill of the operators, some errors from the operators. Now we'll explain Gage R&R study, GRR study. So in gauge repeatability and gauge reproducibility, in repeatability basically single operator with the single same instrument take the measurement, the same part, take the measurement multiple times. You have repeatability. So the variation from the instruments. Now in reproducibility, multiple operators using the same instrument take the measurement of the same part multiple times. You have reproducibility. Normally in repeatability, a single operator will be there. There are 10 shafts are there, and the operator will take the measurement of the bearing diameter. For a single shaft, it will take the 3 readings. So for the 10 shafts, it will take 30 readings. Okay. So the variation that will come from it is from the instruments. Now in reproducibility, there are 3 operators are there, 10 shafts are there. Each operator will take the measurement of the bearing diameter for 3 times. So there are single operator will take total 30 readings. So 3 operators are there. So there will be total 90 readings. And along with that, one appraiser will also be there. He will also take 10 readings. So total 100 readings will be there. Okay. So that's how you can find the reproducibility, the variation that can come from the operators. Now we need to understand some variation. So actually, variation is nothing but measurement system variation and the process variation. Okay, actually the measurement variation should be equal to 0, but it doesn't actually come 0. So there is some acceptance criteria which I will explain in the next slide. Now we need to understand here the variation types. There are common cause of variation and a special cause of variation. Common cause of variation means what? There is some slight pressure rise, slight change in temperature, or some natural variation like machine wear and tear. Okay, all these things comes under your common cause of variation. But special cause of variation means what? High bearing vibration, high bearing temperature rise. Okay, all these things comes under your special cause of variation. For special cause of variation, you need to give proper attention so that you can solve the problem, so that you can make the process stable, and then you can go and study the capability of the process. Okay. So that's why variation is also important. Now in measurement system, there are some variation that is coming. That is basically your gauge repeatability, gauge reproducibility, and part to part variation. So Gage R&R variation should be equal to less than 10%, less or equal to 10%, and NDC, number of distinct categories, should be greater or equal to 5. That is basically okay, acceptable. If percentage of Gage R&R is 10% to 30% and NDC 2 to 5, it is conditionally acceptable. If Gage R&R variation is greater than 30% and NDC less than 2, it is not acceptable at all. Actually, that measurement variation should be equal to 0, but actually it doesn't happen. So what is the acceptance criteria? This is the acceptance criteria that I have mentioned. Now NDC, number of distinct categories, for that I have made a separate video. You can go and check from our YouTube channel. I'll give the link here in the I button. Okay. So if I make a summary, so we have defined the measurement system analysis. We have told about the acceptance criteria of the measurement system. We have told the special cause of variation, common cause of variation, and the key components of measurement systems. And the most important terminology in the measurement system is basically Gage R&R, Gage repeatability, and Gage reproducibility. That also we have explained. So we have covered almost all the things. Okay. So if you found this video helpful, make sure to like the video, share this video, and comments below with your thoughts on measurement system analysis. Whatever you have learned today in this video, share your experience in the comments. I'll be happy and obliged to see your comments. Subscribe to our channel and turn on notification for more insightful content. So I just want to take the opportunity to thank you all from the bottom of my heart for being part of this journey with the Lean System world. So thank you. Thank you so much.